All right, let's jump right in. We all just turn on the tap and we expect clean, safe water to come out. It's a given, right? But what happens when it isn't? Today, we're going to talk about a new kind of detective, an AI detective that's being trained to keep our drinking water safe, especially when things go wrong.
Yeah, that's a question you hope you never, ever have to think about, right? But when something does go wrong with water quality, the response has to be lightning fast. It needs to be precise, effective. We're talking about public health here. The stakes are just incredibly high.
And listen, this is not some far-off what-if scenario. This is real. Just look at what happened in Devon in the UK back in the summer of 2024. This nasty little parasite, Cryptosporidium, contaminated the water supply. And the result? It was chaos. We're talking 40,000 residents getting boil water notices, and get this, nearly 400,000 bottles of clean water had to be delivered by hand. It's a huge disruption, not to mention a serious, serious health risk.
You know that Devon outbreak? That was just one incident. It wasn't some freak occurrence. Check out this number, 541. That's how many drinking water incidents were reported in just England and Wales in 2023, in a single year. So yeah, this stuff is happening all the time, and trying to manage it all, it's a massive challenge.
But here's the interesting part. Every single one of those incidents, it gets documented. A detailed report gets filed, what happened, what went wrong, what they did to fix it. And over the years, all these reports have piled up, creating this, well, it's like a giant library of lessons learned. And when I say giant, I mean huge.
So the data we're talking about today, it covers a solid 14 years of these reports. We're talking from 2005 all the way up to 2018.
And in that time, they documented over 2,300 different incidents,
which led to more than 4,000 different outcomes. And each of those outcomes is a story, right? It tells you what worked, what completely failed, and if the regulators were happy in the end. Okay, so here's the real problem, the big challenge. We've got this incredible library of experience, all these lessons learned, but it is just way too big for any human to handle. Seriously, no single person, not even a whole team, could possibly read, remember, and actually use all that information. So what happens? That valuable experience gets lost. Different water companies end up responding in different ways, and worse, they sometimes make the exact same mistakes that have been made before.
So the million-dollar question is, how do you unlock all that knowledge? Well, this is where it gets really cool. Researchers have come up with a solution that uses two different kinds of AI. The best way to think about it is like a detective duo. You've got two partners, each with their own special skills, teaming up to crack the case.
First up, you've got the veteran detective. This is an AI method called case-based reasoning, or CBR for short. This one is the old-school pro. It methodically digs through all 14 years of records, looking for cases that are just like the current one and figuring out which solutions actually worked. Then you've got the clever partner. This is a generative AI, kind of like the chatbots we're all familiar with now. This partner is super fast, brilliant at getting a quick handle on the situation, and whipping up an initial game plan.
Let's dive a little deeper into that. Case-based reasoning. The concept behind it is actually pretty simple and honestly kind of beautiful. It works on a really logical idea. Similar problems usually have similar solutions. Makes sense, right? So when a new incident pops up, it instantly scans its entire database, all 2,300 past cases, to find the ones that are the closest match. Then it just looks at what actions led to the best results in those cases.
And what about that generative AI partner? Well, this is the same kind of tech that powers things like ChatGPT. It's been trained on just enormous amounts of text, but for this specific job, they fine-tuned it using all of those water incident reports. So you can give it a description of a brand new problem, and bam, it instantly spits out a clear summary and a basic response plan to get you started.
But wait a second, how does this system even know what a good outcome looks like versus a bad one? Great question. So here's how they did it. First, they had human experts go through hundreds of old cases and score the outcomes on a simple 1 to 10 scale. 1 being a total disaster and 10 being absolutely perfect. Then, they took a really powerful AI, this one's called BERT, and trained it on those expert scores over and over until it basically learned to think like them. And once it was trained up, they just unleashed it on the entire library to score all 4,000 outcomes.
And how well did that training work? Honestly, the results were just mind-blowing. An older version of the AI they tried was only about 61% accurate when compared to the human experts. But this new BERT model, a whopping 98.1% accuracy. That's almost perfect.
It essentially learned to tell the difference between a great response and a terrible one just as well as a human.
All right, theory is great, but let's see this in action. Let's put our AI detective duo on a real case. We're going to go back to that cryptosporidium outbreak in Devon and see exactly how this system would have helped the team on the ground in real time. So, first on the scene is our clever partner, the GenAI chatbot. You feed it the basic info, we have a cryptosporidium incident, and boom, instantly it gives you a summary and a draft response plan. And look, it's a great place to start, it's relevant, it's helpful, but as the researchers themselves point out, it's also pretty general. It's the big picture. And that's the cue for our veteran detective, the CBR system, to step in. This is where we go from the big picture to the nitty-gritty. It digs way deeper than that general summary to give you specific, actionable advice. And the best part? It's all based on cold, hard data from every similar case over the last 14 years.
So in a split second, the CBR system chews through all 144 past cryptosporidium incidents in its database, and it immediately flags the most common culprits. What's at the top of the list? Things like deterioration of the raw water, problems with the coagulation process, and good old-fashioned plant failure. Just like that, the response team knows exactly where to start looking.
But here's the real game changer. The system doesn't just tell you what might be wrong, it tells you what to do about it. It analyzes every single action taken in the past and ranks them by how well they actually worked. The data is crystal clear. The most successful first moves are taking more water samples and immediately reviewing the treatment processes. Those actions have an average success score of 8.0 and 7.9 out of 10. Think about that. You're getting a data-driven, prioritized to-do list in a matter of seconds.
So, when you put it all together, what does it all mean? It means that by pairing up these two different AIs, we're not just reacting to problems anymore. We're responding smarter, we're responding faster, and we're responding way more effectively than was ever possible before.
And really, this isn't a competition to see which AI is better. It's all about the partnership. It's a perfect tag team. The Gen AI gives you that quick and dirty summary to get the ball rolling, and then the CBR system comes in with the detailed, data-backed playbook to guide the most critical actions.
The end result here is pretty amazing. You get a system that leads to better, faster decisions, which directly lowers the risk to public health. It also helps water companies stay on the right side of regulations. But maybe the most powerful thing here is that it lets the entire industry learn from itself. A lesson learned the hard way by one company in one city can now instantly benefit everyone, everywhere, for years to come.
You know, this whole incredible system was built just by unlocking the wisdom hidden inside 14 years of old reports. It really makes you wonder, doesn't it? It leaves you with this one big question. What other priceless knowledge is just sitting there waiting to be discovered, locked away in some other industry's hidden library of data?